another presentation on the topic of FRP. Are you interested? Yes, you are. Hi, I'm Hossein Roghani, a PhD student at the University of Miami. This is a work has been conducted at the University of Miami again with help of my friends Camilo, Nafis, Dr. DeCasso, under supervision of Dr. Nani. It's a kind, I can say it's a big issue for the FRP providers, FRP suppliers, manufacturers, that they are working internationally, and also for the researchers, contractors, designers to find out which material specification works better, it's more economical, it's easier to use it. Okay, and we have many different building codes all around the world, many different material specifications, each building codes referring to a specific material specifications. For example, in the US, if you go to the ACI 440 documents or other related stuff, you see that they are all referring to the ASTM codes. If you go to the Europe, you see they have their EN, their ISO, they are referring to all those stuff. And the same thing for Canada, I don't know, Egypt, Iran, all the countries, they are referring to some specific documents. So, but why we are going to harmonize all these documents? First, I can say the main important thing are international FRP providers because they are dealing with many different contractors all around the world. They have to be compliant with a specification of different countries that will increase the material verification cost. So in terms of the economy and also their mental health, it will extend the process and makes the process complicated. And the next guys who are suffering are the researchers, contractors, owners, and designers. There's a lack of consistency in these specifications that cause the confusion to make a decision which one we are going to use. There are some advantages. I think there should be more, but here we have 4 of them. It will decrease the material verification costs, no more confusion, decrease process time and complexity. And also at the end, we are going to provide a harmonized database that satisfies requirements of all the specifications. So the material provider, I mean the suppliers, manufacturers, instead of receiving different certificates to work in the Europe, in the United States, in the Middle East, all around the world, they will just receive the certification from one specific database and they can work all around the world. Here are the properties that we investigated for these material specifications. They are physical properties, mechanical properties, and durability properties, like fiber content, glass transition, temperature, degree of cure, tensile properties, bond strength, shear strength, tensile fatigue, alkali resistance, and if you go to these material specifications, in some of them you may see 10 of these properties, 7 of these, 5 of them. Some of them will not cover the durability properties, but we try to look and find whatever we can. So there are several differences and similarities in these specifications in terms of the number of specimens, size of the specimens, and limit criteria in terms of minimum and maximum. For example, the bond strength, one of the specifications says, for example, 1900 KSI, another one says 1100 KSI, and also the loading rates. For example, I mean, for the tensile properties, maybe ISO said a specific value, and the ASTM says another thing. So in this research, we have worked on 6 documents, 4 from United States, 1 from Canada, and another one from Europe. So there are many other material specifications and building codes that we have to consider for the publications, but as of now, we have just 6 of them. ASTM D7957, acceptance criteria number 554, AC 521. This, and also the last one, FDOT, which is Florida Department of Transportation. These documents are from the United States, and then CSA, which is from Canada, and EAD from the Europe. When I submitted my presentation, maybe a month ago, in that time, we didn't have the new STM, which now is out for the ballot. So recently, I have added this slide. It's a great opportunity to talk about this new STM. They made many changes. They Now they cover the basalt FRP also. Recently, in the previous one, that was a refreshment which came out in again to 2022, but they didn't have the BFRP, the basalt. So they made some more changes. Previously, they had the bench bar in this ASTM code, but now just they have the straight cut lengths, and for the bench bar, they still refer to the previous versions. They include two different grades of FRP. So the FRP bars have different modulus of elasticities. We have type 1, type 2, type 3, and this type 1, 2, 3, it again depends on the specifications. You're referring to the CSA, you're referring to the ASTM. For example, now in this new ASTM, we have two grades. Still, I think they are not sure about the name to call them grade 1 and 2 or grade 8.7, 6.5. But as of now, I can say there are two grades on this, but in the previous one, there was just one. So it was the grade 6.5. For example, they made some changes for the transverse shear and bond strength. Now they are using the mean value, but in the previous one, they were using the guaranteed values. For example, they increased the bond strength limit to 1900 PSI and many other stuff on the material specification, and also some other parts related to the retest, rejection statements, which are not out of the scope of this research. So here's the ASTM D7957, the previous version, which is published now. Again, it just covered the GFRP, straight bars. It provides the limits for different size of the FRP. For example, if you go to the Europe in the ISO, in the EAD, I mean, a European assessment document, you will not see the limits. So there are the differences. And also these two tables are very familiar for the FRP researchers and manufacturer. In the first one, they talk about the property limits and test methods for the qualification, which is different for the QC and the certification. It's another thing that, for example, the qualification will be more important for the manufacturer. They have to, for example, at least they have to test 24 samples to receive the qualification. But when you go to the job site, the engineers they have to run the quality control and the certification. And again, there's another confusion. Which one should I follow? The 24 samples or the 5 random samples for the QC? The next document is another one in the United States. It's acceptance criteria for fiber reinforced polymer bars for internal reinforcement of concrete members. So it will not cover the external and also the fiber. So it's just the internal reinforcement. This one covers GFRP and BFRP. It's the difference with the previous ASTM 2022. It covers the test methods, property limits, specimen size, and they are all similar to the ASTM 7957. The limits are the same as 7957, but the test methods, for example, for the tensile, you have to go to 7205, but they are all ASTMs. It's for straight bars, stirrups, and ties, so it will not cover the bends. It's another difference with the previous ASTM. Also, it considering accelerated environmental exposure and also exposure to the fire. So there you can see other ASTMs that refer for the test methods, not the limits. The other one is again acceptance criteria and another document from ICC, International Code Council. It's acceptance criteria for fiber reinforced polymer bars and meshes for internal reinforcement of non-structural concrete members. So this one is non-structurals. Most of the applications are the flat works, slabs on ground, footing, plain concrete, which is the main leg of my dissertation. And yes, this one, again, like the previous acceptance criteria, covers GFRP, BFRP, also the meshes, which is the difference. It's for just solid continuous circular cross sections. So you do not have other type of cross sections. And let's go to the next one. The next documents from the Canada. This one covers more type of fiber type: GFRP, CFRP, AFRP, BFRP. G is for glass, C is for carbon, A for aramid, B for basalt. It provides property limits based on fiber types. So there will be no minimum for all types. So if it's PFRP, it has unspecified limits. And this one, the difference is one difference is on the grade. So it has 3 different grades, but in ASTM for now we have 1. Later, hopefully we will have 2 grades. The number of test specimens is different. We have many different tests in these specifications. For example, cross-sectional area, modulus of elasticity, tensile properties. In each of them, you need a specific number of test specimens. For example, you saw that for the tensile modulus, in ASTM you need 24, but in CSA you need 25. In the other one, in FDOT, you need 30 of them. So these are all the differences. And the next one is the European document is for carbon, glass, basalt, and aramid FRP bars as reinforcement of structural members. So this one is covering the structural elements. The previous, I mean, the one for on 521, AC 521 just was to cover the non-structural application. This one is another difference. And this one is based on the ISO standards. The previous documents were American one, they based on the ASTM, but this one is on the ISO. For the EAD, you will not find any limits for the properties. So if you need a limit for for example, bond strength, you will not find it in this document. It's again another differences with the American documents. And again, let's go back to the US, Florida Department of Transportation. This one covers 3 types of fibers, B, G, C. And again, test methods are similar to the ASTM, but the number of test specimens are not the same as ASTM C7957. So I think now you really feel the pain that we have in this research, and the FRP providers has the same thing, because they don't know what they have to do when they want to send this document to the Europe. They have to follow this. When it's a really pain in the neck. So we are going to put all this stuff in the same document and just say, hey, if you do follow this minimum, you're done. Here, because the entire document is too large, I cannot put it here in the presentation. Just I tried to hide some of the columns, rows, and just focus on an example, the tensile modulus of elasticity in all these 6 documents. Okay, the first one is the ASTM D7957, for example, in comparison with the AC5 454. So they are almost the same, because the acceptance criteria refer you to the ASTM. So most of the stuff are the same. In this comparison, we try to, in the final harmonized database, we are going to just have the reference, test method, reference section, or the clause in that document, number of specimens, limit criteria, and some comments on the differences and the similarities. And in the next slide, you see the same comparison for another acceptance criteria, CSA document, EAD, and FDOT. For example, here, you see the number of specimens in the EAD, it says 15, 5 from 3 separate lots. Or here it says that 24 for AC. The other one said 24. The other one said 10 specimens per lot. So it will be 30 specimens. Even if it's referring to the ASTM and it's an American code, the number of specimens is different with the one that you have in the ASTM. So I put some of the differences in these charts that you can see them. So for the tensile modulus of elasticity, for the number of specimens, you see all these differences here. But you see that these 3 Americans are the same. Also, the CSA is the same. And here you see the limits, the limits for the tensile modulus of elasticity. This one are the previous generation of the FRP, but CSA is using the new one. So hopefully very soon we will see this one in ASTM D7957. There's an important note here about the EAD document, which has not mentions the limit. So that's a big issue. And here I put some of the conclusions. This research is not still published, so we may change some of these conclusions, or we may come up with some more new thing after we finalize the final document. Most of the properties have an equivalent method on each spec, because they may have different names for each of those characteristics, different standards on FRP materials, and okay. Even if we have different FRP, different specifications on the FRP, still there are some points in common in some of them in terms of the number of specimens, the limit criteria, or the test methods. Main differences are the numbers, size of specimens, and loading rates. And these three documents, ASTM, AC 454, and 521, are more economical in terms of the number of specimens, because they need 24 samples, but for example, EAD need 25, the FDOT need 30 of them. So this one is like, maybe for the manufacturers, it's easier to run this one instead of using 30 specimens. And the final outcome of this research will be a key document for the manufacturers and designers based on this evaluation, to have a final document that satisfies all the specifications. Thank you for your attention, and floor is open for your comments and questions.